Hello everyone, welcome to this video. In this video, let's proceed with exercise 9.4 question number 4. So here in the question, we need to find the sum up to first n terms of the given series. So here the series is 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus 1 divided by 3 into 4 and so on. So can you look at the pattern and suggest what is the nth term here? The nth term here is given by 1 divided by n into n plus 1, correct? Because for 1 we have 1 by 1 into 2, for 2 we have 2 into 3, for n we would have n into n plus 1, correct? Now as such we cannot calculate what is the sum of this particular term because we do not have any formula, and we wanted to calculate what is summation 1 divided by n plus 1. Now some of you might be thinking that I can do like this, summation of 1 and summation of n into summation of n plus 1, or some of you might be thinking that we can perform it like this, n square plus summation n. But no, we cannot do it like this or this. Why? Because we cannot break it like this, because 1 by 2 plus 1 by 3 we are doing this. This is not equal to 1 plus 1 divided by 2 plus 3, right? So that is why we cannot perform such a thing. So what else is the procedure? We have a procedure which is called partial fractions. So you'll study this thing later on. However, as for now, let me tell you how we can do that. We wanted to separate out these two terms here. So we can do that by assuming that they could be written by some constant a divided by n plus b, some other constant b divided by n plus 1. So ultimately we will solve this thing and we will find what is the value of a and what is the value of b. If they are possibly there, we can then write our terms in that way. So let's do it. Let's first of all simplify this term by taking the LCM. So when you take the LCM here, you would have n plus 1 in the denominator, and then you have a into n plus 1 plus b into n, right, in the numerator. So you see this and this would cancel with each other. So you would be left with 1 is equal to a n plus 1 plus b n. Now here we wanted to determine what is the value of a and what is the value of b. So you can do it by looking like this. So first of all, you can take n is equal to 0. Why we are taking it like this? Because this thing is true for all the n. If this is true for all the n, for all values of n, it must also be true for 0 and for minus 1. Why I am particularly taking 0 and minus 1? Because 0 would make this term as 0, right? And minus 1 would make this term as 0. So when you take n is equal to 0, you would have 0 here, correct? And you would be left with a is equal to 1. So the value of a comes out to be equal to 1, right? So in a similar fashion, you can then take the value n to be minus 1, so that this term would become 0 and you would be left with minus b is equal to 1, or here you would get the value of b as equal to minus 1. So once we obtain the value of a and b, we can substitute both the values here, so that we would have our nth term as 1 by n minus 1 upon 1 minus n. And actually you can solve this thing and see whether this is equal to this thing or not. So you can take the LCM here. So here we would have 1 into n plus 1, right? Here we would have minus n. So this n and n would cancel, and you see this is nothing but the same term, but we are writing it now in some other form, right? In this form. Okay, once you have done that, you have written your nth term like this. Now what you can do, you can write each of these terms in this fashion, right? Separated together. Why? Because otherwise it is very difficult to obtain the sum, because as such there is again no such formula where you can calculate the sum, right? We do not have any such formula to calculate the sum of the reciprocals. So what we can do instead here is, so let's have a look here. You can write, because we wanted to calculate Sn for the first n terms, right? So you can write a1, which is 1 upon 1 into 2, as 1 upon 1 minus 1 upon 2. Why we are doing this? We are using this thing over here. We are substituting the value of n as equal to 1 here into this expression, and we obtain this term. So I can write now 1 upon 1 into 2 as 1 upon 1 minus 1 upon 2 like this. Similarly, our A2 would be written as 1 upon 2 minus 1 upon 3. A3 would be written as 1 upon 3 minus 1 upon 4 and so on. So last term would be as such, AN. Now you see this 1 by 2 and 1 by 2 cancels, 1 by 3 and 1 by 3 cancels, 1 by 4 and 1 by 4 cancels. So all the terms which are in between this would cancel, and the last term here would be 1 upon n minus 1 minus 1 upon n. So this 1 upon n and 1 upon n would also cancel with each other. So finally we would be left with 1 minus the first term here, this one, and the last term here minus 1 upon n plus 1. So we can rationalize the term here and we would have this as our answer. Right, so this is the sum of first n terms for the given series. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.